First thing we do, they've already given us a coordinate system. I'm going to stick with that coordinate system rather than moving it or making my own. All right, so here's our shape. So the first thing we want to do is break it down into simple shapes that we can find the area of easily and the centroid of easily. So and again, there's not one way to do it, but the fewer shapes, the better usually. And if you can avoid cutout shapes, it's a little bit easier usually, but sometimes you have to use cutout shapes. So shape number one is, I'm going to call this entire triangle. Shape number two, the square. I think what you meant, and this is what I'll do, I want the entire square. So I'm ignoring in shape number two the fact that part of it is cut out from that circle. So shape number two is a 3 by 3 square. Or shape number two is a 3 by 3 square. Shape number three, this is where I think it's a little bit different than what you said. Shape three, I'm going to take this half circle. Again, ignoring the cutout piece. So shape three is a half circle, and then shape number four we're going to then cut the circle out that we previously included in the material that we include in shape two and shape three. In shape four, we're now going to remove that so that the net effect is the amount of material that we actually have. So we included this in two, we included this in three, so we have to remove it now in four. All right, so triangle, square, half circle, full circle. All right, questions on how I broke this down into four shapes? All right, now, one and two, you could have kept together as a trapezoid. I would say just use simpler shapes even than trapezoids, so rectangles, triangles, in this case a half circle, a full circle, sometimes we'll see quarter circles. All right, so we have established the shapes, so now we can start our table. So we have four shapes. So we're in 2 dimensions, so we'll need the area of each shape. This will be measured in square feet. We're in 2 dimensions, so we'll have an x tilde and a y tilde. This will be in feet. And then we're going to multiply the area times the x tilde, y tilde. So shape number one, our triangle. What will the area of shape number one be? Right, so 3 times 3 divided by 2 is going to be 4.5 square feet. Shape number two, the square. Right, 3 by 3, 9. Shape three, the half circle. Maybe not as a number, but conceptually, how will we calculate the area of the half circle? Right, so generically, pi r squared over 2 would be the area of a half circle. So of the half circle, it's 1.5 squared times pi over 2. So in decimal form, 3.53 to 3 digits. And shape number four, that full circle, now we would use pi r squared. The cutout shape, though, only has a radius of 1. So it will be 1 squared times pi, or 3.14 to 3 digits. And now shape number four is a cutout, so its area is going to get a negative. So these are all filled shapes or positive shapes. This is where we're cutting out the material that we kind of, not erroneously, but we included where it shouldn't have been in shape 2 and 3. We make up for it with shape number 4. So if we add these 4 numbers together, this will give us the total area of the red shape. So the total area is 13.9 square feet. Questions on calculating the area? All right, so now the slightly harder part. So x tilde for the triangle, so shape number 1. What will the x tilde value be? Right, so 4 feet, because again, from its right angle, it's going to be 1/3 of its base, or 1 foot, but we're measuring from the common origin, so we have to go 3 feet and then another 1 foot to get to the x location of the centroid of shape number 1. So +4 for x tilde for shape number 1. Shape number 2, what's its x tilde value going to be? Right, 1.5, because it has a base of 3, and it's half of the base if it's a rectangle or a square. Shape number 3, I don't expect you to know this right now off the top of your head, but for exams or quizzes you need to. If we have a half circle, the distance from the flat side of it is going to be 4r over 3 pi. And then from the bottom of it, it's just going to be r. So again, this filled in half circle, somewhere around here is going to be its centroid. So this distance will be 4r over 3 pi. So to 3 digits, that's going to give us 0.637. Again, the x tilde, y tildes are measured with respect to the origin. So from the origin, we have to go to the left by 0.637. So this value is going to be negative. And shape number 4, what's the x tilde location for shape 4? Right, because the center of the circle lies on the y-axis, so this is going to be 0. Right, questions on the x tilde values here? So these are positive because they were to the right of the origin. This is negative because it was to the left. The sign on these has nothing to do with is it a positive shape or a negative or a cutout shape. Because from its right angle, it's 1/3 of its base away. So this distance is 1. But from the origin, I have to go an additional 3 to get there. Right, any other questions on x tildes? All right, so now we can move on to the y tildes. So shape number 1, what's its y tilde going to be? Right, so 1/3 of its height. Again, as measured from the x-axis, which it happens to have its base on the x-axis. Shape number 2, the square. Right, half of its height, since its base is on the x-axis. Shape 3, the half circle. Right, also 1.5, because that's its radius. So as measured from the origin, we have to go up 1 radius to get to its center, or its centroid. And shape 4, also 1.5. All right, so all the hard work is done. Now we just have to go into calculator mode. So ax tilde, we take the a from the row and the x tilde from the row, and we multiply them together. So here we have positive 3.53 times negative 0.637. So we get a negative 2.3 for that entry. And then negative pi times 0, we just get 0. We add up these 4 numbers and we get 29.2. Same idea for a y tilde. We'll get 4.5 times 1 is 4.5. 13.5. 3.53 times a positive 1.5, we'll get in this entry a positive 5.3. Here we have a negative pi times a positive 1.5, so this becomes a negative 4.7. So the one thing to keep track of here is make sure you're keeping track of positives and negatives. Should the product be positive or should the product be negative? Potentially, you could have a negative value here and a negative value here, which would make one of these positive despite it being a cutout shape.
It's not going to matter whether we go to 100 or leave it at 10.
3 digits is fine for accuracy. I think this was like -4.70.
4.71, but I was just asking because you had the .637 and you had the 3.53 instead of just
Yeah, usually I keep 3 digits. This one, I'll put a third one down there. Rule of thumb, 3 digits is good. If we add this together, we get 18.6. Okay. Questions on filling out the table. We're almost there. So finally, we're ready. We can find the centroid of our shape. So x bar will be the 29.2 over 13.9. So for x bar, we get 2.11 feet. Y bar will take the 18.6 over the 13.9, and we get 1.34 feet.